ideal gas law. So ideal gas law is PV is equal to nRT, where R is your gas constant, 0.08206 liters times atmosphere, mole over Kelvin. So let's look at this problem. Calcium carbonate, the principal compound in limestone, decomposes upon heating to calcium oxide and calcium dioxide. So I'm going to stop there and just write my reaction. And then look if I need to balance. Calcium, calcium, 1 carbon, 3 oxygen. Nope. So then keep reading. A sample of calcium carbonate, so this, is decomposed, and then carbon dioxide is collected in a 200 milliliter flask. After decomposition is completed, the gas has a pressure of 1.3 atm and a temperature of 31 degrees Celsius. How many moles of carbon dioxide gas were generated? So, because you have a 1-to-1 mole ratio, you can simply look for the moles of carbon dioxide. PV is equal to nRT. You want N, which makes PV over RT. So then you just plug everything in, always wanting to make sure that it's in the units of R. 1.3 atm times the volume, which is in milliliters. So you would want to convert to 50 milliliters to 0.25 liters by dividing 1,000 over your R. Times your temperature, which you also have to get to Kelvin, so plus 273.15, or just 273, which is 304 Kelvin, and then you get 0.013 sig figs moles of carbon dioxide. The gas pressure in aerosol can is 1.5 atm at 25 degrees Celsius. This is a practice of gas laws. And you won't be sometimes told which type of gas law you have. So we are here given a pressure and a temperature. Assuming that the gas obeys the ideal gas equation, what is the pressure when the can is heated to 450 degrees Celsius? So just because it says assuming that it follows the ideal gas law, doesn't mean that you need to use the ideal gas law, because the ideal gas law was created from a couple of different gas laws. We know that at constant volume, the gas temperature is directly proportional to the pressure of the gas. So that gives us our gas law equation, P1 over T1 is equal to P2 over T2, where here we are solving for the pressure, so P2, which will then give us pressure 1, temperature 2 divided by temperature 1. So I have 1.5 atm times my second temperature, 450 degrees Celsius. Now, since this obeys the ideal gas, it's good to convert your temperatures to Kelvin, so 25 degrees Celsius, because of the gas constant. Even though you're not using it, it relates to the ideal gas law. So it's good to always just convert to the units of the gas constant. And then 450 plus 273 is 450 plus 273, 723 Kelvin. So then your second temperature divided by 298, and then multiplying all that together gives you 3.6 atm, and that is your pressure.